Hello again everyone, welcome back to ptet.chemistry channel. In this lecture tutorial or lectorial as I call it, we will go through these ideas on chemical structure and bonding. So having done stats of matter as well as atomic structure, we will now start to think about how these little atoms, individual atoms, can then form ions, and how these individual atoms can then join together to give you compounds, or how the ions can join together to give you compounds. And we'll also revisit the idea of molecules versus compounds, something you have done as part of elements, compounds, and mixtures not too long ago. If you need a recap, you can always go back to the atomic structure topical playlist, and inside there you find all the lecture tutorials as well as all the work that you have done for your own corrections, as well as it's important to actually take note of all the little things, the mistakes, and any misconceptions should have been corrected before you actually move on, because once you have a wrong idea set in, then it's very difficult to get rid of it. Just like bad habits, once your bad habits are there, it's very difficult to get rid of it unless you are really determined to. So chemical bonding, so we're doing chemistry and we talk about bonding. So when you have atoms coming together, we will experience this sort of electrostatic interactions. First of all, as you can imagine, electrostatic is to do with positive attracting negative. And don't forget that in an atom, we have the nucleus of an atom. The nucleus of an atom consists of protons and also neutrons. But neutrons have a relative charge of 0. Neutrons are uncharged. Protons have a relative charge of +1, and you have quite a lot of protons in, well, depending on which atom you have, but the nucleus essentially has a positive core or positively charged nucleus. And then you have the electrons surrounding the nucleus in the electron shell. When we talk about bonding, we are thinking about the valence electron. So valence electron refer to outermost shell electron. Outermost shell electrons. This is an electron. So this is an electron. Okay. So valence shell is the same as outermost shell. So shell is not electron, electrons are not shells, electrons are electrons, shells are shells, okay, where the electron live. The electrons are the individual subatomic particle. So you can imagine the electrons being negatively charged will be attracted towards the positively charged nucleus. However, the negatively charged electrons will repel each other, just like the positively charged nucleus will repel each other. Alright, hence you can never get two atoms occupying the same position at the same time, because they actually have a nucleus core. They cannot be two things that appear at the same time, at the same place and same time, because the plus and the plus will repel anyway. Okay, so that is basically what these two statements are saying. Repulsion between the two positively charged nucleus. You also get repulsion between the negatively charged electrons. Of course, we get attraction between oppositely charged particle. So the protons inside the nucleus is attracted to the electrons, which are negatively charged. So how do we get chemical bonds then? Every single chemical bond that you will learn in this topic comes down to the idea of electrostatic force of attraction, okay, between something and something, which is, well, between something and something else which are oppositely charged. All right, so there's the idea of electrostatic force of attraction. We talk about chemical bond because these forces of attraction are stronger than the forces of repulsion. Okay, so whenever we talk about chemical bond, we're talking about the force of attraction strong enough to hold the atoms together. So different types of chemical bonding exist as a result of the different sort of electrostatic interactions. If the two nucleus, so nuclei is the plural for nucleus, if the two nuclei have equal forces of attraction for the bonding electrons refer to electrons that are involved in forming chemical bond, then you will get sharing of the bonding electrons between the two nucleus, because they have equal force of attractions for the bonding electrons. This will give rise to covalent bonds, something that we will not visit straight away, but something that you will learn in about a week or 2 weeks time, or at least in the next lecture tutorials. That is true if both the atoms are non-metallic. Alright, so they will share electrons and give you covalent bond. However, if the atoms are metallic, then you will get something called metallic bond. Okay, metallic atoms will be elements because metals are elements. But then the non-metals can be elements, but also can be molecules which are not molecules which are not elements as well, if they have different atoms. If, however, one nucleus has a much greater attraction for the bonding electrons than the other nucleus, then the bonding electron will be transferred. Okay, so we're talking about the transfer of electrons from one atom to the other, because one of the atom has a much greater attraction for the bonding electrons compared to the other one. So one likes to gain, one likes to lose the electrons. Then we will get something called ions, I-O-N-S, and that is the formation of ionic bond. Typically you'll see in books will use ionic bonds, but somehow there are some books which will use electrovalent bond. Ideally speaking, we prefer ionic bond because that is generally what a lot of people understand, but just because they don't use this often, if you see this in book, electrovalent bond refers to ionic bond as well. Okay, so just stick with ionic bond and you'll be happy. Because a lot of books, a lot of past papers, a lot of teachers or students, they would be this would be the conventional term to use, although this has the same meaning. Alright, so in the previous topic, when we did atomic structure, we talked about noble gases having electronic configuration that have a fully filled outer shell. Okay, fully filled outer shell, and that is stated in the syllabus exactly under atomic structure. This can be an octet. Octet refers to full electron outer shells, or it can be a duplet, because duplet is true for the first shell, which is helium. Okay, so I wouldn't be too worried about this next statement. You don't really do quantum shell, not in O level, but the idea is that atoms likes to form bonds in order to achieve a stable noble gas type of electron configuration, and this can happen through the loss, the gain, or the sharing of electrons. Remember earlier, we will lose and gain if one atom has a greater attraction for the bonding electrons, and the other one will have a greater attraction to one likes to lose, one likes to gain. That is what gives rise to ionic bond. When they have equal sort of attraction for the bonding electrons, then it will lead to sharing of the electrons, sharing of the bonding electron, which lead to covalent bond, or in the case where the atoms are metallic, then you get metallic bonds. This is basically just reiterating what I just said earlier. In summary, chemical bonds can be divided into two types: interatomic. So inter refers to between. Interatomic, between the atoms. Intermolecular, between the molecule. So these are very important, and we only get molecules when we have simple covalent molecule. This will make more sense as we use it more and more in the future. So as I mentioned here, intermolecular forces between the molecules only for simple molecular structure. Simple molecular structure is the same as simple covalent. The molecules that have simple molecular structures are what we call simple covalent molecule. So the structure is simple molecular structure, and these are simple covalent molecules. And these include noble gases which exist as single atoms. If you look back to your elements, compound and mixtures, the exercise that you did, some elements like noble gases, they just like to exist as single atoms, whereas other molecules such as hydrogen, oxygen, I don't know what else, nitrogen, chlorine, bromine, etc. So they like to exist as diatomic, meaning two atom molecules, but the atoms are the same, therefore these are also elements. The other type, of course, is the interatomic bonds, chemical bonds between the atoms. We've got ionic, we've got covalent, we've got metallic. each of these is a technical spelling. You shouldn't have gotten them wrong to begin with. And we talked about earlier between what sort of interactions. So ionic interaction is a result of one particular atom having a greater affinity or attraction to gain electrons, and the other one like to lose electrons. So it's between ions. Covalent and metallic is actually between atoms, where the atoms are actually non-metals, so they like to share electrons and give you covalent bonding. Where the atoms are metals, they would just form metallic bond between the metal atoms. Alright, so that's the end of part 1 of this lecture tutorial, and catch me in the next lecture tutorials where I'll focus more on ionic bonding. So moving on to ion and ionic bonds, we have quite a lot of these learning objectives to cover. So first of all, is a recap of what we have done in atomic structure. Describe the formation. Describe means using words. Okay, so we have to think about gain or loss. All right, so cations are positive ions, meaning the atom has to lose electrons, and the anions are negatively charged ions, so the atom gains electrons. If the atom loses electrons, so your number of protons will be more than your electrons. If the atom gains an electrons, your number of electrons will be greater than the number of protons. Next bit, describing the giant lattice structure of ionic compound. Regular arrangement. Regular arrangement refers to solid. Remember, solid particles are arranged regularly. Okay, ordered arrangement, and you have alternating positive and negative ions. Alternating because the positive will be attracted towards negative, the negative will be attracted towards positive. If you just show positive, 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 surely they are not attracted to each other, but this is positive, negative, alternating. And it's a giant lattice structure. Be very careful. Giant lattice structure. It's a massive network, giant, and lattice structure because it's repeating as a regular arrangement, regular arrays of alternating positive and negative ions. This is definition of an ionic bond. Electrostatic force attraction, a strong one, between oppositely charged ions. Okay, the charge here is with the ED because this is referring to oppositely charged ions. Describing the formation of ionic bonds between ions of metallic and non-metallic elements. So metallic elements like to lose electrons because it's closer for them to lose electrons and get noble gas electronic configuration, whereas the non-metals like to gain electrons because it's closer for them to just gain electrons to obtain or to attain or to achieve a noble gas electronic configuration. We are going to have to use a dot and cross diagrams in order to show the formation of the ions. And when you show the formation of the ions using the dot and cross, you will also show the formation of the ionic bond between the resulting oppositely charged ions. Okay. Lastly, in this 2.4.5, it's just basically explaining properties. This is application of what we know about the strength of the ionic bonds that we have formed. Depending on what cations and what anions you have, you can have different strength of ionic bond, and we will be thinking about the different structure and bonding. Okay, of course, these are all ionic compounds. They will have giant ionic structure, and their bonding will be strong ionic bond. However, there are variations, there are differences in melting point and boiling point, as well as electrical conductivity, because these are all common. These are all common to ionic compounds. Just generally, they have high melting point and boiling point because of the strong ionic bonds that you need to break when you melt and when you boil ionic compounds. They can also conduct when aqueous or molten. Aqueous mean in water, molten mean as a liquid. So this is pure, this is impure because it is a mixture. When something is dissolved in water, it is a mixture, whereas as a liquid, melting point, states of matter, melting point is a horizontal line. Pure substance melt at a fixed temperature. Only impure substance have a variable, have a melting point or boiling point that are not fixed. That's what we call variable melting and boiling point. But ionic compounds have poor conductivity when it's solid. Remember that in the solid state, your particles only vibrate about fixed position. And when you only vibrate about fixed position, your ions are not free to move around. If your ions are not free to move around, therefore we say no mobile ions. Mobile in this case refer to can freely move around. But in the solid state, as you know, states of matter are very important. Your solid particles, in this case, is ionic compound. So your particle refer to the solid. Solid particles, in this case, refer to the cations and the anions. They only vibrate about their fixed position, cannot move around. If they cannot move around, they do not conduct. They can conduct here because they can move around easily. All right. So moving on to the first bit, formation of ions, we talk about atom being uncharged. So we have equal number of protons and electrons. An ion is charged, that means when you have unequal number of protons and electrons, you wanted to gain or lose electrons in order to achieve noble gas group 8 electronic configuration. I mentioned all of these already, and it's just a recap of your atomic structure, so you should be very happy with those. If you are not, then you should really recap those stuff until you're happy with it. All right. Ionic bonding. Ionic bond is a strong electrostatic force attraction between two oppositely charged ions formed as a result of the transfer of one or more electrons from one atom to the other. So this atom likes to lose electrons. This atom likes to gain electrons. Something likes to lose electrons, something likes to gain electrons. You will get ions, which are oppositely charged, and the force of attraction between these oppositely charged ions give rise to this strong ionic bond. They have a giant ionic structure. When you have ionic compound, the structure is giant ionic structure. Okay, so giant ionic structure or giant ionic lattice structure is defined as regular arrangement of that alternating positive and negative ions, because we are talking about giant ionic lattice structure. And this is basically a simple diagram showing the representation of the giant lattice structure. As you can see, they get repeated, and each each Cl minus, which is the darkened one, is surrounded by 1, 2, 3, 4, 5, 6 Na plus, and around each Na plus is surrounded by 1, 2, 3, 4, 5, but it's repeated above, so it's actually there's a 6 one as well. So around each Na plus is surrounded by 6 Cl minus. Around each Cl minus is surrounded by 6 Na plus, and therefore you can see that you can hopefully see that from this representation. Now that is how it actually looks like in reality. In textbook as well as in exams, on paper, we are usually asked to show using dot and cross. We show the atom first of all. So I don't like this 2 plus 8 plus 1. I probably prefer 2, 8, 1 like this, and this is 2, 8, 7 as we have done previously. So you will say this one loses 1 electrons because first shell, second shell, third shell. Okay, so third period number 3, and this is the outermost shell, this is the valence shell. It shows number 1, so there's 1 outer shell electron. It's in group 1, sodium is in group 1, likes to lose 1 outer shell electrons, and you can get neon electronic configuration. 2H7, chlorine is in the period 3, 1, 2, and 3. First shell, second shell, third shell, first row, second row, third row. Period 1, period 2, period 3. Altogether, it has got 17 electrons, but in the electronic configuration, you can see that the valence shell or the outermost shell has 7 outer shell electrons. So that is group 7, all right? So it likes to gain 1 more electrons, then it can get the noble gas configuration for argon, all right? So this one will gain 1 electron very happily in order to go to this thing, which it will be a Cl minus, and it will be 288, and this will be Na plus, which will be 28 electronic configuration like that. This is an atom. This is an atom, sodium. This is a chlorine atom. This is the resulting product, Na plus and Cl minus. Now I have oppositely charged ions. All right, the two oppositely charged ions are attracted to each other by forming ionic bond, and the ions are nice and happy, having achieved noble gas electronic configuration where the outermost shell, where the valence shell is completely filled. Okay.